Okay, so let's get started then. So thanks for coming. Great to see several grids of square boxes with initials in them. This is certainly a bit different for me, doing my first conference talk virtually, but would probably help me a little bit for those of you that are willing to, just to share your video as well. Will make it a bit easier for me just to get the feeling that I'm actually talking to some human beings rather than just to myself. So that would be appreciated. But anyway, let's get started then. So today's talk is going to be on Pharma and how we can make ARM templates pleasurable or at least less painful to author and deploy. So yeah, let's get to it then. So just a little bit about me. Yeah, so my name's Isaac Abraham. I'm the founder of CIT. We're a consultancy that do F# and Azure consultancy. We do training, devs, and so on. I've been a .NET developer since a long time now, .NET 1.0, so right at the early days. Been using F# for a few years now. From my accent, you can tell that I'm British, come from London. I live in Germany now, right in the middle. I'm yeah, Microsoft MVP for a few years as well. Originally, I think it was a C# MVP, then I think it was a .NET, then it was Visual Studio, and every year the titles seem to change. Obviously, I can't do a show of hands so easily, but for those of you that are participating either in the chat or in the that are sharing your screen, would be good just to I'm assuming that some of you or most of you are .NET developers. Some of you will know something about F#, maybe a little bit, and some of you will know something about Azure, maybe ARM templates as well. So you don't need to know anything about F# really or .NET, to be honest, in this talk. It's mostly going to focus on the Azure side of things and some of the decisions and concerns and compromises we make when we're making sort of working with ARM templates. So what I'm going to cover is a kind of an overview for 5 or 10 minutes or so, just about how we go about creating infrastructure in Azure today. We'll talk about then ARM templates and the good things and the not so good things about them today. Then about Pharma, why I created it, what it really does, who it's aimed at. We'll look at a demo of it, talk about some automation, things you get with Pharma, and then give you some instructions or guidance on how you could start using it today. What are the ways that you can really work with it? So on that then, let's get moving on to then this Azure deployment today thing. So the real question I would start with is why don't we automate infrastructure? So this is really about, you know, we talk a lot about CI and CD. People deploy software often. You know, we have automated builds. We use things like GitHub Actions or Azure DevOps, and we have Cake and we have Fake and so on. So we do builds, we do automated testing, we do deployments of code into infrastructure, whether that's on-premise or in our case, it's going to be in Azure. People don't often do the automation for deploying infrastructure though. So we tend not to do that. And the question is really, why is that? And why don't we consider that in the same kind of thought process? And I think there's kind of two parts to that. One is we tend not to think of infrastructure automation as something that we're going to need every day. It might be something that you consider you do upfront and never touch again. Or B, it's just too much of a pain to do. It's not as easy to do as you know, a build process. It's more complicated by definition. Ironically, Azure's got lots of different ways of doing infrastructure deployments today. You know, you've got a number of different options. In some ways, I would say we almost have too many options. It's not always clear about what to use and when to use. And if you look at the documentation, you might not always get a clear and consistent answer as to what to do and when to do it. So I'm going to go through some of the options, and I basically got this list based on just Googling and seeing what hits came up from, if you Google like Azure deployments and web app deploy and so on. I think the first one that most people start with is just to use the portal. You know, it's pretty easy to get started. You've got a GUI, you can click, there's a wizard that takes you through it and so on. It seems to be quite quite a good place to start. Of course, it's not repeatable unless you're going to use something to script your browser or something like that, which tends not to be that workable. It doesn't scale. If you're someone in an ops team trying to create infrastructures, as your infrastructures grow larger and you have more of them, it becomes more of a pain. It's also time consuming, you've got to click around, and it doesn't really apply to code as much as infrastructure. So if you take an example of a web app, you can go into the portal, you can, click buttons to create a web application, but then when it comes to actually deploying your application into that web app, the portal doesn't really have a great option for that. It gives you FTP details or other things and so on. So it's a kind of a disjointed story sometimes. And the next option is right-click publish from something like Visual Studio. That's also relatively easy to start if you're coming from a development background. You have like infrastructure as code, infrastructure and code. So you can not just deploy the infrastructure, but you can say, I want to deploy a web app, and it will compile your code at the same time, which is great. It's again not repeatable. It doesn't scale particularly well, and I'd say it's got limited use cases. You can only use this for the features that Visual Studio supports. So if they don't support cognitive services or they don't support data lake, then you're out of luck. So it's kind of a limited, very focused set of use cases. And everyone always says friends don't let friends right-click publish. So this must mean that this is a bad thing to do. Don't do it. Make of that what you will. So there are a number of other options, though, that have come up in the last few years, really, which is more about code-focused deployments. And I would group this into two categories. One of the services that Microsoft themselves are providing for Azure. So these are things like the PowerShell commandlets, the Azure CLI, .NET Fluent SDK, so that's a .NET SDK, C# that you can use, or F# or VB.NET. There's also a REST API that underpins those three services, or those three tools, that you can go to directly as well. So you can call HTTP endpoints to actually create different resources. And then you have ARM templates, which are kind of on their own to an extent. They work slightly differently to the ones above, but essentially, if you've not used them before, ARM templates are JSON files that essentially are a way of declaratively declaring what your infrastructure should look like. So it's a document that says, I want to have a web app with a SQL server and they should be connected. And please take the connection string from the SQL server and put it as a setting into my web app, sort of thing. There are also a couple of other sort of options out there. So there are services like Terraform and Pulumi. Terraform is an interesting one. It's a document kind of approach. So you again have a document similar to ARM templates in one sense, but it's more of a DSL on top of ARM or relative to ARM. And they have their own sort of state service they bundle with it that gives you some benefits. Pulumi is more of a conventional code-first approach. So it has JavaScript SDK, I think TypeScript, C# and so on and so forth. And they also are multi-cloud, just like Terraform. So you can deploy not only to Azure, but to AWS, GCP, and so on and so forth. In terms of architecturally how these kind of sit, you can imagine that you've got this REST API, this HTTP REST API here, and then you have PowerShell and the Azure CLI and the .NET Fluent API sort of sitting above that. So they can call these endpoints for you in a nice way. Also, you have on the right, you have this Resource Manager API, which is a kind of different set of services to the REST API on the left that is specifically designed to work with the ARM template. And one of the things this gives us is this ability to do what we call idempotent deployments. So basically with an ARM template, you can fire this JSON document at Azure, and you can fire it as many times as you want. And if nothing has changed after the first deployment, Azure will just happily say, fine, nothing's changed. I don't have to do anything. And then you can incrementally make changes to your JSON document, and every time you deploy, it will automatically understand what the diff is. We've got these state services that I put there in the middle, which basically are custom services that Pulumi and Terraform offer, which do idempotency as well, but they give you other things on top of that as well. So it's a kind of a separate way of working. I should point out that the Azure client also does do some form of idempotent checks, but it's not exactly the same as the way that ARM templates work. If you've got any questions, I think I've got no problem with you actually just unmuting yourself or going into the chat and asking straight away now. I'd rather in some ways that you do that than wait until the very end. So feel free to sort of ask questions as we're going through this. On the other hand, if you want to wait until the end, we can do that then as well. Let's get my mouse back. Cool. So there are some good things about ARM templates. Firstly, as I said, you get idempotent deployments. You get support for basically all of the Azure resources in this JSON document. It's cross-platform, you've got cross-tooling support, so you can basically create these JSON documents and upload them directly into the portal. You can use the PowerShell commandlets, you can use Azure CLI, you could upload it via HTTP. It's pretty nice, and you have some decent audit trail as well of deployments. So every time you send a deployment up to Azure, it will log that deployment, it will show you what you sent in, what you got out, what the result was, and so on and so forth. But these are essentially all deployment features you'll notice from here. So what's really wrong? Why aren't I looking at it when it's got all these nice deployment features? Why wouldn't I want to use it? So my background was I was using ARM templates already. We were doing deployments for customers, and we were getting some pretty good results. The deployment experience in general, actually, once it was all set up, was pretty positive. You know, we had it set up with continuous deployments and pushes to certain branches and so on. That was great. The problems we really had was the authoring experience to build these templates up wasn't positive. That was the bit that I thought there's an opportunity here to improve the experience, really. So I would sort of categorize people that work with ARM today in kind of two categories. There are people that are working with it, they know what they're doing, and they're kind of experts. And what I often hear, and I read in blogs even, you know, I got this working, this is absolutely awesome. Look at me, I've got a web app with a Cosmos DB database and a storage account, and it's all configured perfectly. Everyone says that, but everyone also says it was a real pain to get these templates up and running in the first place. No one denies that. On the other hand, you have people that are starting out with ARM and starting out with infrastructure services, and they go online, they Google, they look at ARM templates, and they say, oh, this looks pretty interesting, it sounds quite positive. Within an hour or two, they've given up, and they go back to doing things the old way. And this is where I think part of the problem is the deployment bit is great, but to get to that, the investment and the cost up front is pretty high. For people that know what they're doing, the cost is either something that they've ameliorated because they simply know everything that they're doing, or B, they know the benefits of it, so they're willing to absorb that cost. And they know what's in store for them, basically. So I would say when people are figuring out ARM today, what they do is kind of 3 steps. There's basically a website which has got on GitHub. It's a GitHub repo, which is like ARM Templates 101. And it contains samples for all sorts of different use cases and scenarios. So you've got, you know, create a web app with a storage account, create a web app on VNet, and so on and so forth. So typically what you'll do is you'll say, oh, I need to create a storage account and a web app. And you look on this 101 and you'll find some samples. Invariably, they won't match exactly to what you need. And then you spend the next hour or two trying to pull out the bits that you want and avoid the bits that you don't want. It's not a great experience. Another option that people tend to do is they go into the portal, they create the resources manually, and then one of the things that Azure lets you do is to generate an ARM template for you based on what you've manually provisioned. The problem with that is that A, you still have to try and figure out what's going on, and B, sometimes these generated templates don't actually work properly. So I wouldn't rely on them either. The last thing you've got is the official docs. So you can go to the reference guides, you can look at every single property on some of these templates and see if they sort of help you out as well. But as we'll see later, that's not always a great experience either. So I would sort of categorize the bad parts really in ARM templates at a high level is A, they're really expensive to create and maintain. They take a long time to author, they're really verbose. 2, they're error prone. They're just JSON documents at the end of the day. You get some type checking, but it's pretty minimal. And it's easy to go and do things wrong and only find out after you've deployed, you've waited a few minutes, it comes back with an error. Try something else, you wait a few minutes, comes back with another error. It's weakly typed because it's JSON. There is no type system as such. There is some support, but as I'll show you later, you reach the boundaries of that relatively quickly. It's a low level of abstraction, so the ARM templates are really geared towards the services that Azure provides you, rather than how I think we tend to reason about services and products on the Azure service that we want. For example, in Azure, we think of web apps as a single thing, but Azure treats them as actually two separate components, service plan and a web app. And it's got somewhat limited capabilities. Because it's a JSON document, there's restrictions on how much you can actually do in this. You know, the ARM team have done a great deal of work into trying to build effectively a programming language into a JSON document. So you can do things like expressions and for each loops and variables and parameters, but it's all within the context of a JSON document. So there's always going to be limits you're going to reach on that front. And there are some things that are really ugly. There's a lot of documentation you need to read through to create even trivial templates. Even with some of the tooling support that's there that we'll talk about shortly, you reach those limits pretty quickly and you need to go to the docs after a while. The documentation, I've got to say, it's often outdated, it's unreliable, it's poor, it's inconsistent. So you might go onto one website on docs.microsoft.com and find one recommendation for how to create a certain resource. You'll look on another page and you'll see something completely different. And then you'll go to the GitHub samples and you'll find that they're using an older version of the SDK. There doesn't seem to be one golden source of truth that you can go to answer questions like, how do I do this today? What's the right way of doing it? It's also an inconsistent experience across resources because the way that ARM has been sort of divided up in terms of services, it's dealt by individual product teams. So the Cosmos team and the web team and the SQL team work in different ways, and they have different strategies for how they do things like error reporting or how they organize their ARM templates, how they structure them. So it's not always that you can learn one resource well and then find another one that works in exactly the same way. Sometimes it's almost completely different. And it's slow to validate and fix. As I said before, you have quite a slow turnaround time. If you want to actually prove that things are working, you sometimes don't get errors in the template when you're working locally, but you'll deploy it and you will get an error. And sometimes it's the inverse. You'll get an error in the template as you're typing, but actually it works fine when you deploy it. Not great. About 6 months or 8 months ago, I think, Microsoft announced a load of tooling support to try and solve this problem, which, you know, a lot of people thought was great. You had things like a language server. So VS Code now has kind of language server support for ARM templates. There's code completion now. Sounds nice. You have code snippets, so you can rapidly generate code. And you've got some form of schema verification. So we try and get some type checking in. I actually will, on the one hand, it's definitely a step up from what there was before. I'm still not particularly impressed with it. I think we can still do much better than setting these kind of goals. For a start, this kind of support is VS Code only. So if you're coming from another IDE or another background, maybe you're using Visual Studio or you want to use Rider, you can't use that with ARM templates. You've really got to go into VS Code. The schemas, it's basically a limited set and it gets outdated pretty quickly. So unfortunately, the type checking will rely on these schemas, but if the schemas are out of date, then your type checking is out of date. Discoverability is lacking, so the schemas don't cover everything. And you don't really get, you can't, once you get out of the simple cases, you very quickly find that the guidance in the IDE is lacking. You have to go back to the docs, you're back to square one. Code snippets, yes, I can see why they're useful. On the other hand, I was using code snippets in C# in 2005 in Visual Studio. Is this really the state of the art that we're talking about today? Is code snippets really the best way of doing this? I would say, again, not really. And lastly, again, these are JSON documents, so there's going to be restrictions on what you can and can't do inside them. So I would say this is not the answer. Tooling and code generation is a band-aid. I would say that we really need to rethink how we're working with ARM today, how we're working with Azure deployments. I don't think rapidly generating Reams of JSON is going to be the solution to making ARM templates a pleasure to work with and to encourage people to do more infrastructure on Azure through automated code. So I want something that's quicker to author, so I can quickly get results. I want something that's easier to understand and read afterwards. I want it to be cheaper to maintain, so it's low costs. And I want it to be more powerful, that I can actually do more things with less code. So that's the kind of end state of where I see today. How much time have we got? Okay, good, we've still got 40 minutes. So now let's talk about Farmer. So what is Farmer? It's a library to safely author ARM templates quickly and easily. That's really it in a nutshell. The kind of vision for Farmer would be to make it the most efficient and effective way of creating infrastructure today in Azure. I'm talking even more so than using the portal, using the point and click interface. I want it to be even quicker than that, if we can. We may not get there, to be fair, but that's where I'd like to see it go. So what does Farmer offer? So it's kind of got, I'd say, 4 kind of features, if you will, or guiding principles. 1, the ability to rapidly author ARM templates. 2, the ability to rapidly deploy ARM templates. Now, you don't have to use this. You can just use it to rapidly author, but you can also hook into another part of Farmer that lets you do an entire pipeline where you can basically go from nothing to a deployment completely within Farmer. I want it to focus on high-level concepts wherever possible. I don't want people to have to think about the low-level nitty-gritty of a virtual machine needs to have a VNet and a subnet and NSG and so on. I want us to talk about virtual machines and focus at that level. And I also want it to have escape hatches. So if you do need to drop down a level and Farmer's abstractions aren't what you need, you're not stuck within a kind of a walled garden or a closed ecosystem, but that you can leave it if you need to. I would say Farmer targets 3 sort of core groups of users. So people that are new to Azure, that want to do infrastructure, but are finding it too difficult or challenging at the moment. B, people that are already using ARM templates. I want it to be easy for you to transition to using Farmer without having to give up all the deployment processes that you already have today. And lastly, people that maybe can't use ARM today because we're doing things like dynamic deployment. So imagine you've got an application that is dynamically provisioning services for your customers. Maybe someone logs in and says, I want an instance of my service, which is going to create a virtual machine in the background and storage account and a service bus and configure it and so on. I want you to be able to dynamically create these things through code and then deploy it. So sort of high-level benefits of Farmer is it's extremely productive. It's type safe, which as we'll see is actually very useful. It runs on .NET Core. It's open source. It's extensible, and importantly, it's 100% backwards compatible with ARM templates. At an architectural level, where it differs from other libraries, I suppose, is you start with what we call a builder. So a builder is kind of like a logical piece of infrastructure or service or product that you want to use. So in our case, we might say it's a web app. I want to create a web application to host my .NET application on. Underneath that, we will then essentially emit out several different ARM resources, and these will match directly one-to-one with the sorts of things you'll create in ARM templates today. So maybe a server farm, a web app, and app insights, for example. We'll then compose all of these together into an in-memory version of the template. So we'll have then resources, secure parameters, outputs, and so on. And then we'll emit that either as an ARM template, or if you want, we'll go straight to Azure and deploy it for you. And if you elect to use the deployment bit, then we can hook into some other nice features that we offer, like a post-deployment task. So as an example with a web app, we can say not only will we deploy the infrastructure, but we'll also take a folder, zip it up for you, and deploy it straight into the www root folder. So it's more of an atomic action, although from an Azure point of view, it's 2 separate steps. From your point of view, from deployment, it's one thing. So I'm going to jump into a demo now, and I want to go through some examples of some common tasks that we might do. And I'll demonstrate this with using an ARM template to do some of these tasks. I'm not going to do it manually for all of them. We'd be here all day. But I'll show some of them, and then we'll create a farmer application, and I'll show you what the experience is like from that as well. So I'm going to do things like creating a storage account, modifying the SKU, creating a web app, tying a dependency up together, maybe adding a setting to the web app, things like this. I would say these are kind of common things that someone wants to do, particularly from an app dev perspective, which is my background. So I want to create, web apps, and I want to host them in Azure. So let's jump out of PowerPoint and go to demo land. So, question, can everyone see that? So Gareth, I can see your face at least. So give me a thumbs up. Great, thank you. So I've got here an ARM template, and I've just created an empty snippet, which has basically created the basic core of it. And I'm going to start by trying to create a storage account. So we can do that with these snippets that you get in VS Code. So I can go through here, I can type ARM, and then I can look for storage. And then it's automatically generated me some code. So this is the standard ARM experience you get if you're inside Visual Studio Code today. So I'm going to give this a name. So I'll say my storage. And I'm going to say it's a storage v2 account, and that's nice, and premium LRS. So let's change that. And I'm going to make that a standard LRS. Okay. Interestingly, I'm allowed to actually leave premium as the tier, although the name is standard. I'm actually not sure if this would even work, but let's change that to standard anyway. So it's fine, good. So I've now got one resource. Let's create our web app now. So I can hit a comma there, and then I can say web. So I've created a web app now, and again, it's generated me some code. I've got, 10 lines here. So now I've got my web app. It's now created me that, and it's also asked me to fill in this thing called a service plan. Now, if I've never used Azure before, or ARM templates, I'm not really sure what this is. I know what it is. A service plan is kind of the host that your web app lives in, and that's where you choose the SKU and things like that. So I'll call it my service plan. I don't know where this lives yet at the moment, but it's going to be referenced there. And now I can type plan, and now it's created me a service plan. I'll give it the same name, so it links together. My service plan. And now I'm sort of done. So great, I've got now a service plan. It's all hooked together. It's done this thing depends on, which basically says this web app needs the service plan to first exist. If I want to change the SKU, I can go here. I don't get any suggestions now. So this is, I assume, because the schema doesn't have the SKUs in them. So at this point now, if I wanted to change the SKU or find out what F1 actually meant, I've got to go to the documentation. Capacity. All right, that's been generated there. I assume that means number of instances, maybe, but we can't really be sure here. So this is like the basic kind of approach that we see. I've even actually put this at the wrong level now, so this wouldn't even actually work. So I'm going to just move this back out. Let's paste it back there. Now we should be good. Let's get rid of that guy. Okay, good. So, so this is kind of the experience today. Now I've created a storage account, a web app, and a service farm, and I've got, 50, 60 lines of code. Now I've only had to type a few things to get this, but already now we've got kind of a maintenance issue. We've got some tooling here. So if I go on to the left, I can see this ARM template outline, which is quite nice. Again, we're sort of saying, though, that the code itself, we're acknowledging we can't really use that to reason about the template. I've got to resort now to a GUI. I've got to resort to now jumping out and clicking and pointing and stuff. Okay, fine, that sort of helps. If I want to start making changes, not really sure how to do it. What about if I wanted to add a setting to my web app? I know you can have settings in Azure web apps. How do I do it? So I hit comma. Maybe I get some IntelliSense here. No. Maybe it's inside properties. Site config maybe, but there's no template, there's no snippet for this, so I'm stuck again. Got to go back to the documentation. So I've left my natural flow. So this is just doing the most basic thing. Imagine I said I wanted to do something like make this web app depend on the storage account. So I can try and do this now. I can say resource ID, and this is only because I know what I've done this before. I more or less know what I need to do here. But if I didn't know what resource ID was, I'd be stuck here again. Is that right? I guess so. So now I've said my web app depends on my storage account. Okay, great. If I change this though, now I don't get any compiler support. This won't work because I've renamed this guy, but that one doesn't rename, and so on. I'm already reaching the limits of what I can easily do. So at this point now, I'd say, let me try and do the same thing in Farmer, show you the dev experience of that, and then we'll talk about some of the benefits as well that we get with this. So I'll leave that there. So how do I create a Farmer app? So a Farmer app is just a .NET app. So I'm going to start by creating a console application. Saying lang F#. So I've got .NET Core installed. That's essentially all you need to really start getting up and running. So I've created an empty console app. The next thing I need to do is to add Farmer to this project. And because we're running on .NET, it's just a NuGet package. So I can say .NET add package Farmer. And now we're good to go. So what I'm going to do is remove this code. And I'm going to try and do the same thing as we did before. What I'll do is I'll leave this in a kind of a watch mode where as I make changes to the code, it's going to regenerate the ARM template every time. So I'm going to start by opening up the Farmer namespace, and I'm going to create an empty ARM template to start with. So I'll say template equals ARM, and I'm going to set the location to, let's do West Europe, which is where I am. And the next thing I'm going to do is emit this. So I'm going to say writer.quickwrite to output. So that's now going to generate my template to output.json. And okay, good. Right, let's carry on. So am I right that I was just at the point here, Gareth, I'll rely on your nodding here, where I was just showing you how I'd opened and generated an empty ARM template? Is that more or less? Great, okay, good. Let's keep going then. So this is even more of a challenge now. Can I create a storage account and a web app and connect them together in the space of 5 minutes? So let's start. So I'm going to create a storage account, which I'm going to call my storage. So I have to open up a namespace now called farmer.builders. So this is basically opens up and gives me access to all of the, I'm not sharing my screen. Oh, sorry, right. Share content, good spot. Right, here we go. Can you see the screen now, guys? Yes, good, right. Okay, so I've opened up a namespace called farmer.builders, and I'm going to start creating a storage account. So I'm going to say let my storage equals storage account. And we open up braces, so it's kind of a similar experience to JSON, and I say name my storage. And then I can go down here and say add resource, my storage, and hit save. And now because I was using this .NET watch run, it's basically just monitoring every time I make a change to this file, and it's going to regenerate the ARM template on the right here. So now we've got a storage account, and it will generate it with some basic defaults. So sets up the SKU as standard LRS, sets the location to West Europe, so it will implicitly take the location that I've set at the ARM level and automatically cascade that down to my storage account. And I get other sort of keywords here. So if I want to set the SKU, I can say storage, and now I get IntelliSense for all of the different SKUs I've got. And this isn't a string, so I can't just type standard LRS. Yeah, these are actual types, so it's not a string but a SKU. So we get some type safety there as well. So if I wanted to change that to, let's say, a standard GRS, I make the change, I hit save, .NET will pick that up, and then I've got my new resource. So while we're doing that, I'm going to create a web app. So we'll call it my web, and it's a web app. And again, I'm going to say name my web app. And what I'm going to do, actually, just to give a fair account and a comparison, I'm going to turn off App Insights for the moment. And we're going to add this resource as well. So now we've got my web. And hit save. And now this is going to generate a web app for us. Now, what does this actually really create for us? So it will create both the two resources that we saw earlier. So it's created, and let me just open up on the right. So let's have a look here. So we've got a web app, and we've also got the server farm. And you'll see that the name is the same name as the web app with just the word farm appended to it. So you can override that if you want. We've basically followed the pattern of least resistance here. So it's created a web app, set the server farm, set the dependency up as well. So we depend on the farm. The farm's there with a basic SKU of F1. But when we're working in Farmer, we don't think of it as two separate resources. It's a web app for us. So I can here say SKU, and I can then say web app. Web.web app. And there I've got all my SKUs as well, so I can change them as I need. So I can say I want a B2. Workers, so how many workers do I want? I'm going to add 2 workers. So that's kind of the basic principle of Farmer, but we can do a lot more than that because we're in a slightly more strongly typed environment. So let me just show you a couple of more tricks that we can do. So let's say I want to add a setting to the app. Well, that's pretty simple to do in Farmer. So I can just say setting, my setting, my value. And we don't have to worry about where this lives in the template. It will do all the work of omitting the appropriate parts of the ARM template that are required. So you look up here, and now we have this app setting, setting, and value. If I wanted to do something a bit smarter, let's say I said I wanted to put the key of the storage account into my web app. Now this is a common pattern that people have. I want to configure my web app to be already configured with a connection string to another resource in Azure. Now, often the conventional way of doing this, even if you're using ARM templates, may be to say, I'll deploy the resources, then I'll go into the portal, find the connection string of the storage account, and then manually copy it into the web app. But in Farmer, we can do much more than that. I can simply say something like storage key, and then the setting value is going to be my storage.key. Now, when I run this, the nice thing is that the resources don't exist, so it can't know the key at this point. What it does is create an expression that is going to essentially build this string up based on the storage account key at deployment time. So we never ever have to put in the secret into the ARM template. So you can essentially go from literally nothing to a fully configured app without ever omitting a secret, which is quite nice. And you can do this obviously manually. I'm showing this here. But I can promise you, if you've never done this before, you'll spend ages digging around on Stack Overflow, on the doc sites to try and find the exact string that you want here. So this makes that a hell of a lot easier. Out of the box, we also will deploy an App Insights instance for you. So if you've never done App Insights before, thank you, Kristen. This will basically create an App Insights resource which does logging and tracing and so on. Not only will it do that, it will create all the settings that you need to have it fully configured. So you have the live tracing, all of the setup and so on out of the box. So to literally create a web app, the only thing you really need is that. And you'll end up with a web app that's got the server farm, a basic SKU for free, and an App Insights instance. We can also set manual dependencies. So if you need to, you can do things like depends on my storage. And now we have a storage, we now have a dependency between the web app and the storage account. Nice. Two things that Farmer deliberately doesn't support out of the box here is variables and parameters. We do support parameters, I'll show you in a minute, in a limited way, but variables you don't really need anymore in terms of ARM templates because you have a real programming language. So let's say I wanted to make an environment variable. So this is going to be something like dev. And I want to have now the names of both of these resources with that environment. Well, that's easy because I'm in a proper programming language. I can just use stuff like this. And this is not a specific Farmer feature. This is just basic F#. You know, take a string, take another string, and add them together. So now, when I look over here, the resources, once it's regenerated, will just be there, my web app dev. And if I want to parameterize this, well, that's also pretty easy, actually. Let's say create my infrastructure, which takes in a parameter called env, and I'm just going to tab this all in. So now we have a function It's going to take in a parameter called env and give back an ARM template. Now down here I can say, create my infrastructure test, and then pipe that into here. So now I've got a function that knows how to create an infrastructure based on some parameters at the top. And I can do conditionals and the normal sorts of things that I would do in any kind of application. So it's important to understand here that we're working in a proper programming language. We have all of .NET behind us. I'll show you one last thing here that we can do that's quite nice. So when it comes to parameters, in fact, let me just undo that quickly. We get things like refactorings, of course, because I'm in .NET, so I can say environment, and okay, code hasn't worked there, it's let me down, never mind. But if I want to do things like a SQL database, for example, we can do something that's pretty smart here. I can say my DB equals SQL server, and I can say name is my SQL server, and the username is Isaac. And now I want to add some databases to this. So I can say DB, let's say SQL database, name my DB, and I'm going to set the SKU as SQL.db SKU, and I'll have I'm not going to use P1 because I'm too poor. I can do an S1. So now I've got, not only have I got those resources, I've now got a database as well, and I can of course get to some of those properties. So in here I could say I want a setting of my SQL connection string. SQL con is my DB, and now I've got there a property called connection string, and I can just pass in the name of the DB, my DB, and that will automatically configure my web app with the appropriate setting in here with a ready-made connection string configured for that database. And we can do some more smarts here because we're working in a proper programming language. So for example, let's say I created 2 more databases. Now I haven't specified the SKU here, so what Farmer will do is create an elastic pool for me and implicitly attach those 2 to the pool. So let's just add on the depends on here, and say SQL. Now, because we're sitting on top of ARM and we're fully backwards compatible, I can also use extensions that work with ARM templates. So I can say preview graphically. So now I'm just going to move this to the side here. And this is nothing that I've built, but I basically can look at my Farmer template and I can see exactly what it looks like once I add in the resources down at the bottom here. So let's add in my SQL. So I can already see I've got my sites, I've got a server farm, I've got a storage account, the dependencies all correctly set up, and so on and so forth. So we get a huge amount of power here. And you can see now I've created 3 databases. Just imagine how much time that's going to take you to do if you're doing this manually with ARM templates. I don't even want to think about it. Last bit of code I'm going to show you, because I've only got 4 minutes left, is we also have a full deploy pipeline. So here I can say something like deploy this to my resource group. And this behind the scenes will sit on top of the Azure CLI. So it's going to delegate that, the CLI to that. It's going to generate the template, call the Azure CLI, and then spit it out. I would have shown you that, but we're basically out of time almost. So I'm going to jump back to the slide decks. The only thing I would point out finally is with parameters. So I mentioned we don't support parameters. It's not entirely true. We support secure parameters. So here I've created a SQL server, and I've said the admin username is Isaac. What about the password? So here we'll already create a parameter for you called password for MySQL server, which is a secure string. So you can supply the parameter. It will never show up in the portal. It will never show up anywhere, but you can still actually use it. Right, let's jump back to Mr. PowerPoint because I'm almost out of time. Right, so some use cases for I have to say I'm really sorry that I've lost 10 minutes there. I couldn't show you everything I really wanted to, but hopefully you got an idea at least enough to convince you to have a look into this. So you can use it for authoring ARM templates, as I've shown you. You can use it for deploying ARM templates where you don't even need to see the ARM template. You just work with Farmer. That's the level of abstraction that you go from. You can use it as part of a build script because we're just in .NET, so you could use cake or fake, so you could have it as part of your CI/CD deployment scripts, download some code. It's just .NET. Yes, it's F#, but you can reference it from C#. That's not a problem. CI/CD pipelines, so there's actually a .NET template that will pre-configure a Farmer app for you with a YAML file for DevOps. So you can basically just create your Farmer file, check it into DevOps, set up a service connection, trust to Azure, and it will automatically start doing the deploys for you as well. And as I mentioned earlier, it's part of a running app for on-demand deployments as well. Some of the benefits you'll get from this approach: one, we work on .NET, so you have a proper programming language. You've got a huge ecosystem. You can call any NuGet package in Farmer because it's just a .NET application. So you could use ones to do naming of your properties. You can do, you know, all of the .NET SDK, BCL, all of that is there. You've got a compiler and an SDK. You don't need to look at you know, custom tooling. We have a mature compiler. We've got Visual Studio. You could use Rider. You can even use Notepad. You know, some of these templates are so small, it's pretty quick and easy to get up and running. But you still can use refactorings. You can use IntelliSense. You know, as you saw before, you get a lot more control that pushes you in the right direction, particularly if you're not an expert with ARM templates. And they're very flexible. I haven't shown you that, unfortunately, but you can basically paste in raw ARM templates or sections if there's a resource that we don't yet support. So you're not sort of in a walled garden or a sandbox environment. We sit on top of the Azure CLI, so we basically will use that for doing the deployments. We have what-if support and we've got validate support directly in Farmer. You can use the portal as well. I showed you a visualization tool. All the deployment side of things, that will all stay the same if you're using ARM today already. Yes, Farmer uses F#. Farmer is a DSL that I've built on top of F#. It's really not difficult. If you've fought your way through ARM templates today, I promise you, what you saw today is not harder, it's easier. So that's really, F# side is really not a reason. You don't really get exposed to the full language if you don't want to. Just to re-drill it in, I did it twice. We don't support arbitrary parameters, as I showed you. We think you can do that directly within your applications. We do support secure parameters. We don't need variables. We don't support linked templates yet. If there's a good use case for that, we will build it in. I'm not yet seeing that really. And we don't support every feature of every resource. We currently support around 40 resources. So we support everything from Cosmos to SQL to service bus topics, Azure queues. You know, we basically have taken a kind of yeah, I'll say here, an opinionated view. So we basically have we target the 80% of maximum utility for 20%, the 20% of effort sort of thing. We're not going to spend loads of time on the corner cases, at least for now. How do you get started? Download .NET Core, download either VS 2019 or Rider or VS Code and the F# extension called Ionide. There's also a .NET new template, so I did it from scratch today, creating a console app and adding the Farmer package, but there's basically a template that will do all that for you. .NET new Farmer. There's also a doc site, which I'll show you very quickly just now. So let me jump over to the browser, if I can. There we go. So, Gareth, can you see that? Is that my browser yet? Great, thank you. Composition, here we go. So we have obviously we have the GitHub repo, but we also have a website, if you can believe it or not, where we basically have all the documentation here. So we have all of the resources we support. We've got documentation on every single keyword that you can use, how to use it with a sample. There's quick start guides as well. So there's basically everything you need to do to get going. And we also have a nice comparison that shows some of the areas where ARM templates are stronger than Farmer and some places where Farmer is definitely a good use case for you. Let's minimize that again. What about Pulumi? So that's a common question. Pulumi is absolutely brilliant. I would definitely recommend you check it out. It works at a slightly different level. So Farmer, I would not say is a direct compete. Pulumi is multi-language, multi-platform. Farmer is F# on ARM templates. There's obviously, if you're not using ARM templates or you don't want to and you don't want to use Azure, Farmer's not for you. But if you are using it, we can obviously make decisions, which means we can combine and craft this DSL to be a really, really, really nice fit for ARM templates and for Azure, that I think you might find more difficult to do in Pulumi. We don't do the state management either because we're at the behest of what ARM supports. So if ARM were to do this in the future, that sort of thing, then we would do it. Pulumi obviously has that as a service. How can you get involved? Just try it out. So it's just a NuGet package, .NET add package farmer. You can contribute to the project just giving feedback. So you can message me on Twitter or Slack. You can give GitHub issues. You could add documentation, even add new resources if you want, and share knowledge with others. So, you know, I think we've got something that if you're looking to do infrastructure today, that's Farmer can really help on Azure. Tell people about it, let them try it out as well. I'll just end with those links. So GitHub I just showed you, .NET F# for learning about F#. You probably won't need it really to use Farmer though. We've got no time for questions, so I would say we jump straight to, I'll be in Slack in either the hallway or the room if you want to ask me there. Drop me an email or Twitter. I'm not sure if we've got time for questions, Steiner. Basically, exactly 12:40 now. In fact, we're 3 minutes over.
It's an hour break now, lunch, so you can do questions. You can
okay.
Go over
Right.
it. Yeah.
So right. If more questions, just unmute yourself and just ask me now, or I'll look on the chat if I can figure out how to get to that. Okay, good. Let me see if I can get the chat open. Okay. Can you reference things that aren't deployed through Farmer? All right. Let me go up to the top. Great. Yes. So all right. I'll take the questions one by one. Any specific for F# there? Any specific reason? Yes, there is. F# has much better support for both custom DSLs than C# does. And secondly, it's got a stronger type system. So I didn't really show you this today, but think about cases in ARM templates where you'll have a property that you will only add if you have another property as well. So this kind of grouping of properties and mutual exclusion. F# allows you to model that very, very well with things called union types that C# doesn't have. So to model that kind of illegal states is much easier to do in F#. Plus, from my point of view, it's much more productive to developing it as well. You don't actually have to because the way Farmer works is just with .NET interfaces. So if you want to create your own implementations and your own builders or your own resources, you can do it as C#, just implement the interface and you're good to go. Can you reference things that aren't deployed through Farmer? Say you have separately deployed Key Vault and want to use a secret in it in your service deployed through Farmer. Yes, you can. So you can do a dependency and pass in the exact full expression of the resource that you want to depend on, for example. We don't have great support for that, I'll say, because most of the time we're doing things directly, you know, the entire infrastructure in Farmer. There is support to do it. We could probably make that a bit easier. So you're not the only person to ask about Key Vault. That's a good example of where maybe another team are managing your secrets and you simply want to get to it inside your app. So that's a good example where we could maybe make that a bit better, but it is possible to do for sure, yes. Is the production ready? Well, we're using it with 2 of our customers. So yes, it is. I would say we're still making changes to the API, that's for sure. But those changes are much fewer and far fewer than they were, say, 2 months ago now. We went through a big sort of refactor of the API in the surface area. It's much less now. We're basically just at the point where we're adding new resources. So I would expect us to lock it down and get to a V1 in the next few weeks, I would think. Can Farmer generate parameters files? We use this to differentiate between dev and prod in the pipe. No, it can't, except for, as I mentioned before, secure parameters. But the way that we see Farmer working is, if you want to use it for parameterization, use Farmer rather than creating an ARM template and then parameterizing that itself. So what we would have is actually the app that I created today. That would be part of your pipeline that actually does a .NET run and then generates the ARM template on the fly and deploys that. If you want to go the other way, you can do it, but then you'll have to create your own parameters files. And we did start, to be honest, with supporting that, but it made the whole API much more complicated because then you have to support parameters, variables, and literal values. So it makes the actual API more difficult to consume and harder to work with. So we made the choice, for better or for worse, that we don't want to support that. We might change that in the future, though, to be fair. Yeah, so you have to deploy 2 times with different parameter values. Yes, so if you had a dev and a test environment, what I would suggest is you build your app, your farmer deploy, routine or your cake script, and you would pass in different parameters that would be fed in naturally through your environment. So that might be environment variables or whatever else you need, but that's how you would do it. Or it could be part of your app. So you could say in your farmer app, if I'm using the dev environment, I want to have S1, B1 SKU for my web app and 1 worker. And if I'm in the prod version, then have 3 workers and it's S3. So you can choose. I mean, you're in .NET. I just think we should get out of my personal view, at least, is we shouldn't we don't have to replicate the exact pipeline that is currently used in ARM. I agree it's a bit different to what we're used to, but I don't see it as a problem. At least it's not for us. Okay. Seems to be about it then. I can only apologize again for missing out on 10 minutes of the talk. I hope I was able to give you an idea of the sorts of experience it is, though. Yeah, great, thank you. And yeah, I encourage you just to try it out. From my point of view and the rest of the people that are working on it, I'm just interested in feedback. If you try it out and you find, this works, but we're missing this resource, or we need some extra settings, then great. Try it out and give us your feedback, really, because my main goal is not to, I didn't write Farmer because it's an F# tool or it's something different. I wrote it because it was just too expensive for us to create ARM templates for our customers. So we basically just wanted to make that easier, and this is just a means to an end to do that. So keep that in mind. It's working for us and some of our customers. Yeah, that's all I've really got to say. So thank you very much, and keep in touch. I'll be in Slack, so you can ask me there as well if you want to have a look, or maybe we can even set up another screen share at some point. Yeah, exactly. Much more fun, and it certainly is. It's. I find it less of I have more confidence with what we're doing now because it's at a slightly higher level, and it's less of a pain, in my experience. Brilliant. Thanks very much, Steiner. Back to you.